guys, welcome to week 6, testing a claim between two proportions. So what I want you to know about this unit is it is essentially what we did in 8.4. It's similar to that. The only difference is that now we're looking at two sets of data. We're not just looking at one, we're looking at two. So there are going to be a few things that you recognize are pretty much the same. And there's going to be two things, I believe, that are different, and we're going to clear a few things up. Anything that is new is going to be done in this red pen right here. So anytime that you see the red pen, know that, oh, okay, this is actually new. Except for the formula. The formula is kind of new, but I'm not putting that in the red pen. So let's go ahead and begin. The cats are, I don't know where they are, so that's a good sign or a very bad sign. So we'll see. We're going to start with state. The state section does not change. We are still looking for the null hypothesis. The null hypothesis is still going to be P1 minus P2 equals 0. Now the reason why it's P, the capital P, is because that is the parameter proportion. It's the proportion that talks about the population, not the sample, but the population. So this right here, the null hypothesis, says that if you were to take whatever the proportion is of the first set of data minus whatever the population proportion of the second set of data, there's no difference. Your alternative can be one of three things. It will either be that P sub 1 is minus P sub 2 is less than 0, greater than 0, or not equal to 0. We're going to do it the way that we did in the last few videos. So it's going to be one of these three things. It's either less than, greater than, or not equal to. You're also going to want to figure out what is n sub 1, what is n sub 2, your sample size for the first set of data, your sample size for the second set of data. You want to figure out what is p hat sub 1, that's your sample proportion for the first one, p hat sub 2, which is your sample size for the second one. We want to know what is the alpha. Ooh, what else do we typically look for? Alpha. Okay, yeah. And then here is the new part. Wait, do we have standard deviations for? No, we don't. If you have a standard deviation, awesome. If you don't, we are going to be using this. We're going to be using, this is red, p hat sub c. Now, what p hat sub c is the sample combined proportion. So what that means is that this is going to also be equal to the total success over the total surveyed. So that is n sub 1 plus n sub 2. So this is your complete sample size, so the sample size of both studies over how many times it actually happened. So let's go ahead and move on to the next step. The next step is going to be to plan. We're back in the non-red, so we're back to normal. In the plan section, we're going to do what we did in week 4. So we're going to start off with, is it random? Yes or no. If the answer is no, reread it. And then you have to check, is n sub 1 times p sub 1, hat sub 1, is that greater than or equal to 10? Is n sub 1 times 1 minus p hat sub 1 greater than or equal to 10? You also have to check the second set of data. So is n sub 2, the sample size of the second one, times the proportion of the second one, greater than or equal to 10? And is the sample size times 1 minus p hat sub 2 greater than or equal to 10. Tiger just jumped on the table. He's not being super crazy though. In this section, we're also going to go ahead and say, we're going to go ahead and do our curve based on the alternative hypothesis. So if the alternative hypothesis is less than, you're shading to the left. If your alternative hypothesis is greater than, you're shading to the right. And then if your alternative hypothesis is not equal to, you're shading on both sides. Tiger, can you stop? Thank you. Okay, so we can go ahead and put those there. The next step that we're going to do is we are going to do. So in the do section, we are looking for the z value. We're looking for the z value to find the p value. We're looking for the z value to find the z score to find the p value. So we're going to look. The formula, or the do section, is to find z and use table A to find the p-value, to find z-score, and then determine the p-value. Okay, so let's start off with the formula. So the formula, z is going to be equal to, in words, it is the statistic minus the null divided by the sample standard deviation. So, in terms of really long equations that aren't that long, that's p hat sub 1 minus p hat sub 2 minus the null, which is, you guessed it, always going to be 0, divided by the square root of p hat sub c times 1 minus p hat sub c divided by n sub 1 plus p hat sub c times 1 minus p hat sub c over the sample size of the second set of data. Now here's what I know a few of you would be asking in class right now. You would be saying, do we really need to write -1 every single time? And the answer to that is yes. Yeah, you know, it's one of those things where it's really good to write that -0 just so that way you know the correct formula at all times. It's also good in case the null is ever for some reason not 0. It's good to know that that's what the 0 represents. If you leave off the 0, you're going to get to the point where you're like, what's supposed to go here? And then, you know, so it's good to write the -0. You're not going to get the problem wrong if you don't write the -0, but you should. Okay. Now, let's go back to our 3 pictures for a second. Now, after you find your z value, you go into the table and you find that number. So the number that you get in the table is going to be your z-score. Here's a few things that we need to know. The first is if the alternative hypothesis was less than, if it's shaded to the left, then your p-value is equal to the z-score, the number that you find in the table. If your alternative hypothesis is greater than, then your p-value is 1 minus the z-score, And then if your alternative hypothesis is not equal to, then your p-value is equal to 2 times the z-score. Okay, and remember that the z-score is the number that you get in the table. So you get z from the equation, and then you have to find z-scores. So after you do z, after you find z, use table A to find the z-score. And last but not least, what we need to do is, oh, sorry, another side note, just kidding. If z is a number that is less than or equal to negative 3.5. So if you do this equation for z and you get a number that is less than or equal to negative 3.5, then the z-score is 0. Now, if you were to look at table A on the negative side, you could actually see right here how the numbers count up to negative 3.4. Now, as it goes from or up to negative 3.4, all of these numbers are getting smaller and smaller as it goes up the table, to where we get to the point where by the time you get to negative 3.5, your z value is pretty much 0. Alternatively, if your z value is greater than positive 3.5, your z-score is actually going to be 1, because you see right here how all of these numbers are counting up towards 1, but never actually getting there. So once we get to 3.5 and above, we're just going to say that the z-score is 1. So if z is greater than or equal to positive 3.5, then the z-score is 1. And that's really important for you guys to know. Let's look at the last step. The last step is to conclude. Some of y'all love this step. Some of y'all hate this step. So in the conclude, what we're going to do is compare the p-value to alpha. If your p-value is less than alpha, then we reject the null hypothesis. It's supposed to be an E. We have convincing evidence that the alternative is true. That the alternative is true. And then if the p-value is greater than alpha, then we failed to reject. The null hypothesis. We have no convincing evidence. That the alternative is true. Stay tuned for the next video. It's going to be great. It's going to be examples. Have a great day. Bye.